This is video 42 on MicroPython. I noticed a new feature in MicroPython 1.25 called ROM FS while reading the release notes. It looked like a feature that could improve performance. In this video, we present ROM FS and take a first look and then a step-by-step to build and deploy an example. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. For this effort, our test rig uses a standard RPI Pico2W USB board. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal for this effort is to learn about ROM FS and walk through the steps to deploy an example. Here we will present the new feature, which the MicroPython team says is the result of 3 years' effort. We'll demonstrate an example, we'll discuss the firmware, finally we will build and deploy an example. The firmware and code files are at the GitHub site that is mentioned in the description and endnotes for this video. ROM FS defines a read-only, memory-mappable, extensible file system that can contain arbitrary resources, including precompiled MPI files, and it allows executing bytecode directly from the file system. This makes importing and execution significantly faster and uses a lot less memory. For this initial release, the MicroPython team included the feature for several platforms. The important aspect here is that the last item means we can build our own custom firmware. So we did. The ROM FS feature is utilized through the MP remote program. It gives 3 new subcommands: query, used to view the file system; build, to create a compiled bytecode image file; and deploy, to load the ROM FS partition with the image file. So, we built a new firmware for the Pico2W and placed it in the firmware July section of our GitHub. Let's look at a quick demo. Our Pico test rig has a port for I2C devices. We plugged an SSD 1306 OLED display into the I2C port, and I'm ready to verify it with our test scan I2C program. Our Pico test rig has a port for I2C devices. We plugged an SSD 1306 OLED display into the I2C port, and we can verify it with our Thony program. Okay, I've started up Thony. I have the scan I2C program in Thony, and I'm going to click the green run icon. When I do, you can see that the program expects the user to press a button, which will begin the scan process. And it sees the OLED device at hex 0x3c. All right, we know the program works. To perform the build deploy process, we must first install our environment. On my PC desktop, I have a Conda Python 3.12 environment. I must load 2 programs into it. First, I pip install MP remote, and then I pip install mpy-cross. Please notice that I verify that MP remote actually is the version for 1.25. If not, then I need to run the command pip install upgrade MP remote and rerun the MP remote version command to verify that its version now is version 1.25. There are 3 commands that we will perform in the command prompt. First, we want to query to ensure that the firmware has a ROM FS partition. Next, we want to build a ROM FS image using the build command. Finally, we want to load the image into the ROM FS partition using the deploy command. Now that we have the prerequisites and understand the steps, let's do them. We'll open up an Anaconda prompt on our computer. Okay, we've opened up a command prompt on our computer, and we've activated an environment that we've stored MicroPython programs. And let's set our directory to the location of our test program. We'll do a directory, and you can see I have several directories here. Let's go look at the utilities folder. Okay, in the utilities folder, I've placed a copy of the scan_I2C program. Now we're going to use the programs that we downloaded earlier into the Anaconda environment, which is MP remote. Let's CD back out and run the MP program. Okay, I've entered in the command MP remote ROM FS -O for output, utilities.image, and the extension is my own thought, just to differentiate it from the directory and other files. Then build, and then utilities. And what this will do is it will take the contents of the directory utilities and compile anything in it to bytecode. Okay, we can see that it found the scan_I2C program, and it's compiled it into a bytecode and renamed the file .mpy. It's also told us the number of bytes that it is, which is 1074. Let's use the query command to check the firmware and see what we've got there. Okay, so the firmware that has a ROM FS partition, as you can see, it's only 131,000 bytes, and it's not a valid ROM FS yet because nothing's been loaded into it. So we need to make sure that whatever we put into this partition is smaller than 131,000 bytes. So at the moment, our scan program is only 1,074 bytes, so it's going to easily fit into this. Now that we have the utilities image, let's deploy that image using another command. All right, here's the MP remote ROM FS deploy utilities.image. And what it will do is it will take that image file that we just created, and it's going to load it into that partition. All right, and it's just that simple. It's now loaded that image into the partition, and we can do a query, and the query now reports that there's a valid ROM FS image at it. As interesting as this is, let's see what Thony does with it. So let's stop the terminal and bring up Thony. All right, here's the program in our desktop. We can close that. And notice down here that there is a new object called ROM. And in ROM is scan_i2c.mpy. Now this is that partition with the loaded program. So we can simply type import scan_i2c and run that program on our firmware directly. Move the cursor out of the way. Okay, we've invoked the program. We can press the user button again, and you can see we now have the hex address of the OLED, which is hex 0x3c. So into this partition, you can put anything. You can put any file or program that you would normally use in MicroPython. So we could even put font files there. In summary, in this video, we presented the new feature ROM FS. We demonstrated using an example program, and we walked through the build and deploy steps. This feature is good to store utilities and files like font files. Hopefully you learn more about ROM FS and are thinking of ways to use this new feature. Please comment if you feel other changes are needed. I hope this video helps your MicroPython coding. Thank you for listening.